thanks for taking out time today. Today we are going to talk about 5G xHaul. Today we have Pranav Mehta with us. He heads engineering for software and virtualization for our routing and switching portfolio. He has a team of 500 odd engineers across the globe. He is also responsible for driving vision and strategy for 5G, cloud, edge, PON, and NFV. Prior to joining Ciena, Pranav was with Cisco for many years. A bit of introduction about myself. I'm Digvijay Sharma. I head sales for India North and SAARC region. Apart from that, I have responsibilities of Blue Planet software for go-to-market for India and SAARC region. I have been for many years in Siena and have total experience of around 20 plus years in telecom industry.
Thanks, Digvijay, for having me on this platform, and I'm excited to have this chat today.
Thanks, Pranav. So with that, thanks to COAI also for setting up this forum to exchange our thoughts, and we're happy to be here. So let's start with this discussion. So Pranav, being in San Jose, which is the epicenter for all the next gen technologies, startups coming over there, a lot of action happening on 5G. So, and yourself being into this technology for so many years, what are the key trends that you see in 5G technology going around?
A good question. So, Digvijay, if you look at the broadband 5G promise, the promise is to enable the large number of applications and use cases that requires high bandwidth and low latency connectivity. These are the applications that require connectivity anywhere, anytime, to anyone. 5G also promises to enable extended mobile broadband services that provides the high bandwidth internet access to the end user, as well as promise to enable the fixed wireless. The 5G is expected to enable massive machine type communication for IoT applications and sensor networks, as well as ultra reliable low latency connectivity for telemedicine, AR, VR type of applications, for the self-driving cars, as well as some of the critical communication for like 5G, private 5G networks for the first responders or 911 communication. So all these low latency, high bandwidth applications, from my point of view, are leading into three different technology trends. The first trend that I see, which is the obvious one, is the evolution into the mobility infrastructure. So to be able to support these many different use cases and 5G applications, the operators will need to deploy large number of different spectrums and large number of radios and make a huge investment. And since they are going to do a huge investment, that's going to drive better sharing of the resources, the better sharing of the networks, and make networks more efficient. There will be influence into the decision whether operators want to go with centralized RAN or they want to continue doing what they do today, which is a distributed RAN. Whether they want to continue using the legacy hardware BBU, or they want to go to a cloud-based RAN or virtualized solutions. Whether they want to continue with backhaul or they want to go with front haul and in some cases mid haul. The second technology trend that I see is evolution of network infrastructure or networking. As 5G will increase the need for the bandwidth and the mobility infrastructure will need to increase the bandwidth and support for low latency, you will see a lot more demand to go from 1 gig interfaces to 10 gig and potentially from 10 gig to 25 gig interfaces. And a need for a flexible device, a flexible router or flexible aggregation device that can carry CPRI over ROE, eCPRI, or even can do L1 offload to support ORAN mapping, or it can support the low latency and synchronization technologies that are needed to support these CPRI packetized solutions and enable the time sensitive networking. Also, it will it will change the way we have been doing the data center or cloud infrastructure because of the need for these timing and synchronization. And the third evolution I see is innovation to drive differentiated services or premium services. So as operators are going to do the heavy investment, they have to manage the average cost of the devices are not going to go up. So average revenue per device is not going to go up. So they have to come up with some innovative applications that can drive additional revenue. And these differentiated services would require ability to share the bandwidth and drive into the network slicing technologies. So you will see more advanced soft slicing technologies based on different underlays, or even up to the point you will see hard slicing technologies like Flexi to be able to support wholesale networking, to be able to support multi-tenancy, to be able to support private 5G. So in a summary, I think what I see is the 5G is driving technology trends in three directions: evolution of the mobility infrastructure, the evolution of new networking infrastructure, and on top of that, creating a differentiated services based on the 5G networks.
Very interesting. Very interesting, and especially from the service provider standpoint, a lot of investment would be going in. Now, with investment, you also spoke about spectrum. This is a big debate with the next 5G of spectrum auction is going to happen sometime next year, as being discussed. Now, on spectrum, can you shed some light on the need of spectrum and why it is needed, and what is it all about mid-band and high band spectrum? Can you share some thoughts on that?
Sure. So 5G is going to bring the evolution into many aspects. To be able to support these new use cases that requires low latency, high bandwidth, 3GPP has defined 5G to be able to use across a large set of spectrums. For an example, all existing 2G, 3G, LTE spectrums can be reformed to be used as 5G. And this is what we call today narrowband 5G. Although such low end spectrums have extremely good cell coverage, but they are typically limited into the spectrum bandwidth, right? So, enhanced mobile broadband, which is the most important application that 5G is going to drive, that requires the high end internet access or high bandwidth internet access or high throughput for the individual subscribers, it because of those type of applications, 3GPP has defined 5G to be used on newer spectrums like C band as well as the millimeter wave, or what we call it frequency range 2 in 3GPP specification. So now, although these newer spectrums like C band, which is the mid band, and the FR2 offers significant amount of spectrum bandwidth, the challenges with these high-end spectrums is that they are smaller and limited into the coverage areas, and as they are operating at a higher frequency. So this means when you are going to deploy a solution based on these high-end frequency bands, there will be a need to densify your cell sites and even more deploy a lot more radios to be able to get the coverage that you want. Now, it's not going to be impractical that you can deploy these macro cell sites with macro radios at a larger scale because of the cost and even impact of the RF radiation. So instead of deploying these macro sites everywhere, the mobile app operators will need to complement their macro sites with densification of what we call low power radios and low power radio cells, that what I've shown here in this diagram. So now, as the densification gets closer to, let's say, the office complexes, the stadiums, the malls, you are going to have the radios and the cell site that will need to be optimized in the terms of the size, the power consumption, the weight, and the radio emitting power, right? Also, as you are putting these low end radios in conjunction with the macro sites, you will have to properly coordinate these cell sites and their spectrum to reduce the interference between the spectrums, and so that the operator can drive the maximum throughput out of their deployment. So basically, 3GPP has defined the C band and various spectrums to be available over 5G, and various operators will need to figure out what spectrum to deploy into what region to get the maximum out of their investment.
Understand. Now, you also spoke about bandwidth and latency requirements increasing and the relevant use cases. And this is leading to further densification. As you shared, there would be more radios that would be put. Now, all these things are definitely going to put some load on service providers in terms of the way they are, backhauling today, because the network has to be more fiber because of latency, and the densification will increase bandwidth. This is going to put a lot of load onto the existing backhaul network
Absolutely.
infrastructure. So, how do you see them getting evolved when they move on to 5G?
A very good question. So, as operators around the world going to start deploying 5G technologies, there is not going to be one size fits all, right? Some operators may deploy 5G based on C-band, some operators may deploy 5G on other spectrums to be able to achieve the right balance between the coverage and the throughput. So, as I said before, the biggest challenge with this mid band and high band spectrums is that they have a good throughput but limited propagation and coverage. That means you will require to deploy a lot more radios to achieve the coverage that results into densification of the radios as well as networks. Now, as you deploy more radios means more power, more space, more cost, more complexity, especially due to the baseband electronics, which is extremely costly. So, therefore, the operators are going to be forced to optimize their investment, and they are going to optimize the cost by centralizing their baseband unit. And they will aggregate multiple radios over those centralized baseband units to improve the performance, and at the same time connect multiple radio sites with different technologies simultaneously. So now, if you look from that perspective, this results into the need for a front haul transport between the radio site and the centralized RAN and centralized RAN or CRAN hub. Further, in 5G architecture, you can split the BBU into two, what we call a distributed unit and centralized unit. And if you do that, then it also needs something called mid haul. So now you are going to have front haul from the radio to DU, and mid haul from the DU to CU. And from CU onwards, you'll continue doing backhaul to your EPC. Now, the preferred RAN architecture, whether it's DRAN, distributed RAN, or centralized RAN, may vary completely depending on the spectrums deployed, the available fiber. For an example, the operators might continue to use backhaul for their existing LTE deployments, and they may move to centralized RAN for the 5G deployments. Or some operators may say that we want to go to symmetrical architecture, and we would carry and front haul the 5G as well as LTE traffic all the way to the virtualized RAN. So therefore, you can see that you will see different mix into the networks. You will see a different mix of front haul, mid haul, or back haul, what we call it now xHaul. And now, as you see different types of deployments based on different spectrums, it's extremely important what you choose as your network infrastructure. You need a flexible router that can today support backhaul, but later on can be used for mid haul or front haul. You want to choose your next hardware that can support a 1 gig or 10 gig interfaces, or eventually it can also support 25 gig if eventually you end up deploying 25 the 5G radios that has a 25 gig interface. You also want to decide whether you want to carry the CPRI traffic as a radio over Ethernet, or you want to carry the eCPRI traffic. You also want to decide whether eventually are you going to have the new radios that can support ORAN mapping, or are you going to have a mapping using L1 offload? You're going to map one encoding of the radio into the open RAN to be able to use virtualized RAN. So these type of densifications are going to drive various new technologies in the area of front haul, mid haul, and back haul.
No, understand. So clearly there is quite a bit of complexity as we talk about, as there will be so many variants in terms of speeds and feeds, as well as in terms of architecture. Some will have front haul, some will have back haul, some will have front haul, mid haul, back haul. Today we have only back haul and a bit of front haul with CPRI. So there is a lot of complexity. There are different variants. I won't say complexity. There would be different variants that would be generating a bit of complexity, and they have to coexist because of the fact that we would be its switchovers of network is not is 0 or 1. You don't switch over in a day. It takes few years to
Yes.
upgrade the network, and it takes years to turn up a 5G, and at the
Yes.
same time service providers have to serve their 4G customers that are there. So now what definitely we see that these networks and these different variants as well as transition as it happens, these networks are going to coexist with one another. So how do we solve this problem of these different variants, this complexity, and existing of these different networks plus transition happening simultaneously? So what are your thoughts? How can we simplify this this transition?
A very good question, and I think this question is there in minds of every mobile operator on how they can quickly enable 5G but have infrastructure that is future proof, right? So if you look at the India market, in the markets like India, the large scale LTE deployment started in maybe last few years or maybe 5 years. So operators are not going to move to 5G overnight. They are going to gradually move to 5G. So operators are going to continue to use their low band spectrums that they are using for LTE, and gradually they will enable new 5G services. First, in what we call it non-standalone mode, and before enabling so they will first enable in a non-standalone mode before enabling the 5G services or new on using newer 5G spectrums over standalone mode. So for an example, this is the chart that shows um, a plan for one of the tier 1 MNO who has existing spectrums for their LTE radios. What they're planning to do to quickly launch 5G nationwide and have a maximum coverage, this operator is going to reform one of their LTE spectrum and use it to offer 5G services. So this is, Digvijay, going to be a step one for a lot of mobility operators that they convert one of their LTE spectrums to enable 5G quickly, and then later on go into newer spectrums and newer 5G services. So now, in most of the existing cell sites that this operator has, uh, it's deployed based on DRAN solution. So their BBU is on the radio side. So they had to upgrade their BBU to now support the 5G capability. But this enabled them to offer a 5G service immediately over existing 4G infra, in what we call it the non-standalone mode. So, however, they also had to upgrade their cell site router that used to have a 1 gig interface. They had to upgrade that to a next gen CSR that can offer 1 gig, 10 gig, and 25 gig interfaces, and that can do backhaul today, but it can also do front haul or mid haul in the future. So it has to be a flexible enough as a front haul gateway. So as they evolve their 5G architecture, they don't need to reinvest into their mobility infrastructure. So now let's look at what they will do next. So now operators may continue to do their backhaul of 4G and 5G, or they may go in a different way. They may decide to do the backhaul for their existing LTE using the distributed RAN infrastructure, and for 5G, they may go to centralized RAN. Or they may decide that they want a symmetrical network architecture and they want to front haul the 4G as well as 5G. So, considering almost all the 4G deployed 4G LTE radios have CPRI interface, you will see a need for front haul of CPRI traffic using radio over Ethernet technology, in addition to carrying 5G eCPRI traffic over front haul. Now, there are advantages of using Ethernet solution over passive DWDM to carry CPRI, because it allows you to mux the 4G and 5G over a same fiber, as well as eventually, if you want to move to a cloud RAN type of architecture where you have virtualized RAN, you have to carry the packetized CPRI over Ethernet. Also, the newer generation 5G radios support eCPRI, but the first generation 5G radios also only had CPRI interfaces. So even for those radios, you will need to carry CPRI over Ethernet. So as I said, and I emphasize, selecting your front haul gateway or your xHaul router is extremely important to future-proof your network, because 5G technology is going to evolve over years, and you want to select the infrastructure that is capable of supporting various new technologies that might be coming in the future.
Makes complete sense, Pranav. If we have this flexibility that we can take care of different type of front hauls, different type of radios, different generation of CPRI and different haul technologies into one device, that will definitely help us, give us a lot of flexibility in this complex environment while we are transitioning and having different variants of networks coexist together. And it's a really good insight, Pranav. Now, another aspect that is very, very relevant in case of 5G and has been a point of focus is the cloud RAN. RAN centralization with 5G. That's also another key aspect with BBU and CDU getting split from the radio side. So, any thoughts on that?
A very good question. I think Cloud RAN hopefully will be the eventual evolution into the 5G infrastructure. And what I see is 5G was defined by 3GPP as a cloud native architecture to leverage on the virtualization. So operators want to to move to virtualized RAN in a cloud native manner to be able to move away from their legacy proprietary hardware that may result into savings of space, cost, and power. Now, it can also provide a flexibility where eventually you may use open RAN radios, or you can use L1 offload technologies to map one radio technology to another RAN technology. So, similar to existing web scale deployments, the operators can utilize the commoditized COT servers and run virtualized RAN software. But not only that, they can run the other applications like edge cloud applications on these servers. So, Cloud RAN can provide increased agility to the operator to deploy new radios, new spectrums, new 5G technologies, and new cell sites at a much faster pace than you need to upgrade your hardware to go from one 5G technology to another 5G technology. The shift in Cloud RAN and virtualized based solutions will mean that your CPRI radio, the interface that will need to be packetized, it has to be covered over Ethernet. And it has to be converted into Ethernet packet. And this is one of the reasons, as I said, why passive DWDM solution for to carry the CPRI is inefficient or insufficient. The other reason you might want to go with Ethernet is that you need ability to mux your 5G and 4G traffic on the same fiber. So carrying this CPRI brings very stringent requirements on the timing and synchronization. So having a device that can support timing and better timing solutions, more complex timing solutions, low latency solution, and proper synchronization is extremely important. Now, that's where the differentiation comes between the data center deployments and the cloud RAN deployments. Because there is a stringent need for timing and synchronization, you cannot use the data center fabric for cloud RAN. You will need to have a fabric that understands the timing and the synchronization technologies. So, in a nutshell, moving to cloud RAN or virtualized RAN can make a solution more scalable, more versatile, more elastic, and it can help potentially optimize your cost of deployment.
Very insightful, Pranav. We spoke about Cloud RAN. We spoke about band spectrum. We spoke about latency requirements, um, coexistence of these many networks together. We spoke about quite a few topics. Would you be able to give us an insight on how this entire network, Cloud RAN, front hall, mid hall, back hall, all these things put together look in an end-to-end architecture, so that we can envisage it in a single thing.
Sure. So this is what we see as a target architecture for full 5G networks, and it will take years to evolve. But what we
Yeah.
see is that xHaul architecture must support deployment of different xHaul solutions, whether it's front haul, back haul, or mid haul. The front haul gateway should be flexible enough to support various encoding. It should be able to support CPRI or ROE. It should be able to support eCPRI. It should be able to support 25 gig interfaces for the future. And it should support the low latency delivery, and stringent timing and synchronization need. MNOs may eventually go to the cloud based architecture, and they may go and deploy CRAN hubs. They may have additional new applications that can run inside the CRAN hub uh, cloud. Now, to be able to support various applications that we talked about, whether it's telemedicine to AR, VR to self driving cars to a lot of other applications that will evolve in 5G, you will need to provide the proper partitioning of the network, proper slicing of the network, and you need that slicing end to end. It cannot be a piecemeal. So you will need a proper deployment of soft slicing technologies like either MPLS or segment routing, but also hierarchical QoS to be able to provide various services. And in some cases, you might need a hard slice if you want to provide a private 5G type of a network on top of your mobility infrastructure. And then on top, to be able to manage this massive infrastructure and this massive network, you will need a multi domain orchestrator that can create these slices in a seamless way to be able to enable new services on a much faster fashion than traditionally what it takes to
MDS,
enable new services.
something like Blue Planet MDS or orchestrator, which can
Yes.
orchestrate. Very insightful, Pranav. Thanks for sharing your thoughts on end-to-end architecture. Now, this is a lot of investment for any service provider both in terms of dollars, in terms of efforts, in terms of time. Uh, with in India, especially where the ARPUs are going all the time, are lowest across the world, $2 in the vicinity of $2. So, what is in there for a service provider, and how if obviously everybody wants to move to the next technology, and we believe they would, but what are the different ways in which they can get in return on their investments? While all the existing services are pretty much getting commoditized. Any thoughts on that?
A good question, and I don't think it's specific to India market only. I think this challenge is going to be there in almost every market where they enable a 5G technology, right? So MNOs are going to do heavy investment and significant amount of investment into their 5G spectrums and their radio deployments because of the densification. They will also need to upgrade their network infrastructure, lay out more fiber. And so overall, 5G investments are going to be substantial, but it's going to be hard to monetize it just using the monthly subscription fee, right? As you just said, the average revenue per unit or ARPU for customers won't be significantly higher. So the mobility operators will need to look at diversifying and creating differentiated premium solutions to be able to drive more revenue out of their investment. So one area that they are going to be focusing on, as this survey shows, they are going to look at the enterprise customer and leverage offerings for the enterprise customers to increase their overall revenue. The enterprise customers may need now performance sensitive use cases and applications that has very premium services or guaranteed SLAs, and MNOs can offer those type of services. Or some
For a high,
customers may go to private 5G network or multi-tenancy or wholesale. So there are various solutions that MNOs can provide to get additional revenue out of their infrastructure. Now, the radio densification is going to force the mobile operators to deploy a lot more routers and in a lot more dense areas. Now, they are not going to just use these routers to provide the mobile infrastructure, but they can use these routers to enable, apart from the CSR and front hall gateway type of applications, they can leverage these routers to enable the legacy enterprise features. They can support L2 VPN, eVPN, L3 VPN, 6VPE type of features on these devices, and they can get additional revenue out of their mobility investment. Now, I have seen some providers doing more innovative stuff. There are some providers in North America, they provide aesthetically good looking 5G deployments where your 5G radio is hidden behind a LCD screen or a banner to do the advertisements. And they do future proofing by putting the front hall gateway type of router there. But there are cases where you are going to put a lot of those radios in stadiums, into the parks, into zoos, and you can now put the advertisement banners and other things to get additional revenue out of it. Now, apart from the legacy enterprise services, what is going to drive more revenue for the mobile providers is to offer what I call it differentiated premium services. These are the services where they can offer the performance sensitive, time sensitive, new use cases and applications. And as they provide differentiated services, the enterprises are likely going to pay more for the premium performance. So new applications can leverage URLs, LLC, or IoT applications or sensor network applications. And those are the applications, or even AR, VR, that's going to drive the additional revenue for these mobility providers. So now, what, how they can do it? And to be able to do that, they will need to partition the resources in the network to be able to enable those premium services. So they can partition based on soft slicing, and as I said, they can enable enhanced mobile broadband for the enterprises or private 5G type of technologies, or they can go to hard slicing. And in that case, they can enable multi-tenancy or wholesale mobility, or even they can hard slice. I've seen the deployment where a customer has created a flexi-based slice to support 911 type of communication. Also support the first responders over that private network. So, in a nutshell, these providers are going to be challenged to create these innovative premium services to drive additional revenue out of their investment.
Really interesting. So glad to see there are so many differentiations that are coming out and so much of enhanced experience that can be given to the users that can help service providers to charge on the basis of the kind of service that they will be providing to them. Different slices are going to help them create differentiated services. Now that's really that's really interesting, and look forward to see that. Now, apart from thanks, Pranav. Thanks for all these valuable insights. I would like to take some time and would like to share a few things about India and how we are doing a lot of development and R&D here in India and enabling the service providers with the technologies that are made in India, designed in India. Now, soon we are going to add one more chapter, which I'm going to share, which is going to be Make in India in some time. So let me move over to the. Let me give you a brief review about Ciena India. It's really interesting, Pranav, to see that there are differentiated services that are getting created with 5G, different latency profiles, different bandwidth profiles, and that would a different quality of service that would enable service provider to charge differentially on the differentiated services that they are going to offer for different kind of services, and different these network slices are going to enable service provider to do that. So really interesting, and happy to see that there are new avenues coming up for service providers, and so that they can charge differentially and potentially a better ARPU for them. And another aspect is that this routed network, which will be created for 5G, can also be used for various new services for their
Yes.
high capacity, wired customers. So interesting, very interesting aspect. So that we see that all this thing is happening for a business purpose eventually, right? Now, with that, Pranav, thanks for all the overall insights on
Your
the various
pleasure.
aspects of 5G and xHaul. With this, I would like to bring a bit of focus on Ciena India. It has been 15 years since when we are here in India, and we have over 2,000 employees, and of that, around 1,200 plus are just focused on R&D. We're developing a lot of products here, whether it is converged IP routing, and then all of them are designed in India, because and this has been there for quite some time now. We have presence in all the top service providers, offices, complex in top cities in India. The most definitely, since our service providers are covering entire geography of India, we support them likewise, covering entire geography of India. I'll give a bit of more focus what all products and services that we do in India, and then we'll talk about a bit more. So here we develop our converged packet optical transport. We have software development happening here. We have hardware design happening here. We have got product validation testing happening here. Same thing happens for our routing and switching platform, software development, hardware design, product validation. Large part of Pranav's teams is based out of India in Gurgaon, and in Gurgaon happens to be a second largest base for research and development globally after Canada. So there is a lot of development work that happens out of India, and it's not just for one product; it's across the portfolio that we have. We have customer demo labs here, wherein we can demonstrate the latest solution, latest technology to our customers. New product, we can validate their solutions, and we can give them quick turnaround in terms of what they can deploy, what they can't. Now, apart from software development, product validation, hardware design, we are adding a new chapter into our journey. We are going to add another chapter this year into our journey, which is going to be Make in India, basically manufacturing in India. That is going to be a key addition and a big milestone in line with the Pradhan Mantri's Digital India initiative, and a lot of our customers are asking if we can make in India. So here's the good news. Now we are going to make in India. We will make, to begin with, select routing and switching products. We chose these products because of at the advent of 5G, routing and switching is good. As Pranav mentioned, this product line is going to play a key role in the overall 5G architecture. So with 5G in mind, we are selecting some routing and switching products to be made in India. This production will be done in collaboration with our partners, which are helping us globally, and they will set up our shops with them here. And it will not only help the service providers here in India, but also we will not only make for Indian customers, but also we will be exporting to the nearby markets wherever we have some business relevance for these products. With that, we'll end the today's session. Again, to sum it up, I would say xHaul, made in India, and designed in India, and now manufactured in India. Thanks for your time, Pranav. Any closing notes you might want to add?
No, nothing. Thanks for guys attending this webinar, and hopefully you got some new information. And if you have more questions, you can always reach out to Ciena India email address that was in the original announcement and invitation.
Thanks everyone. We are happy to answer, and if you have any questions, and we look forward to your feedback, and look forward to hear from you more. Thank you.